Hello everyone and welcome back to the channel. If you're designing any modern web service, chances you are dealing with RESTful APIs. It's the most widespread architectural style for web communication and for a good reason. But in a system design interview, it's not enough to just say, I would use RESTful API. You need to demonstrate how you would design a good one adhering to its core principles. Today, we are diving deep into the fundamental of RESTful API design that will make your interview answers shine. Okay, so whenever you are in a system design interview, you will hear a lot of whys. Like, for example, I will use RESTful API. Why? I will use GraphQL. Why? I will use a load balancer. Why? And you have to prepare yourself for answering the why question. So why RESTful API is so popular and why you will use it in your system, for example. There are 4 reasons. I guess 5 reasons, might be more than that, but we will focus only on 5 reasons right now. First thing will be simplicity, because it's relatively easy to understand and implement compared to other styles. It's really easy. Number 2, it leverages HTTP. So like REST fully utilized the existing functionalities of the HTTP protocol, its methods, status code, and stateless nature. This means it reuse well-established web standards. Number 3, the scalability. Its statelessness allows easy horizontal scaling, and I would say as any server can handle any request without needing prior context. It's really scalable. It's really scalable. And I might talk about only the statelessness in a next video, or maybe in one of the next videos. But let's just focus right now on the RESTful APIs. And number 4, it's widespread adoption, and also it has tons of tooling. Because there is a massive ecosystem. I guess this is because the community of RESTful API is huge. It's really huge. So you find a lot of tools, a lot of libraries, and a lot of frameworks as well that will support like building and consuming RESTful API services, making development really faster. So lastly, we have the discoverability. I would say the URLs can be often intuitive and self-describing. But this, if you don't understand this, so for example, let me have like a button here, pin. What I mean, for example, if I have like something like users/create, when you look at this, you understand that this is a URL to just create users. So it's easy to understand what each URL is making or is doing from just the name. Because URLs can really be intuitive and self-describing. So it's really has a little bit better discoverability. Okay, so next we have the core. We want to talk about the core principles of RESTful API design. I would say this is not only in your system design interviews, this is in general, you need to understand these. First, resource-oriented. RESTful APIs are built around resources, which are abstract representation of data or concepts, like something like user, post, comment, something like that. Each one of these is a resource. These resources should be identified by meaningful hierarchical URLs using nouns, not verbs. This is very important. Nouns, not verbs. For example, you will have like something like users/id. I typed user, so you have to add s here. Maybe posts/id. Things like that. If you want to get some relationships, for example, you would do something like that. Let's say that we want to get the users orders. So it will be users we will have the ID as variable. ID. I'm pretty bad at typing curly braces. And here I will say orders. And this is the E. And voila, that's it. Also, number 2, use standard HTTP methods. Let me just delete this because I guess we will need it. So RESTful APIs or REST uses HTTP methods to describe the action you want to perform on a specific resource. For example, if we have, this is not a G, if you have a GET, this retrieved a resource or a collection, it's safe and idempotent. We have POST. POST create a new resource. This is not idempotent, and maybe we'll talk about idempotency in a bit. Next we have, I guess, put. Put is it replaces a fully update an existing resource. It's idempotent, and we have patch. Patch particularly update an existing resource, and this one is idempotent. And we have delete. Delete is just delete one. Delete a resource, and it is idempotent as well. And there is a pro tip for you guys: batch and put. You need to focus on them, and you need to understand that put replaces the fully update of an existing resource, and patch partially update an existing resource. Because you'll be asked a lot in any interviews that asks questions about differences between put and patch. Okay, so what next we have? I guess we need to talk about idempotency, because I said get is it's idempotent, post is not idempotent. What does this mean? So idempotency is key. An idempotent request produce the same results no matter how many times you send it. So get, patch, put, and delete are idempotent, while post are generally not, because post you create a new user. For example, in the post you create a new resource. So when you just try to hit the creating a new resource multiple times, you create multiple resources multiple times. Okay, let me just clear everything here, and let's continue. We have the statelessness. So I would say this is the cornerstone of REST. Every request from a client to a server must contain all information needed to understand the request. The server should not store any client context or session state or any session data between requests at all. Everything is stateless. This simplifies server design and enables easy horizontal scaling, as any available server can handle any request. Client sessions are typically managed using, I guess, tokens, like something like GW tokens or cookies that are sent with each request and validated by the server. Of course, this adds more complexity on the client side, but I would say it makes the scalability way more easier. It makes the scalability, way more easier. Not possible, because you can just also scale your system with a stateless architecture, but it will be really hard. And we have here the client side, client server separation. The client and server should be able to evolve independently. Basically, changes to the UI, which is the client, shouldn't require changes to the API server and vice versa, as long as the API contract remains stable. Lastly, we have uniform interface. This constraints emphasizes consistency. Okay, use standardized naming conventions, consistent use of HTTP methods, and standard media type like JSON, for example. This makes your API quite predictable and easier for developers to consume. Okay, next we will talk about some key practical aspects in RESTful APIs for your interviews. First, we will talk about the HTTP status codes. For example, if you have any code that start with number 2, that means success. 200 is success, 201 created, 204 it's no content. for delete. Okay, we have here 4. Everything starts with 4. It's a client error. So 400, it's a bad request. 401, unauthorized. 403, forbidden. 404, not found. And 409, it's a conflict. And we have next, anything starts with 5, it's server error. 500, it's internal server error. 503, service unavailable. And yeah, and the correct sales code provide immediate feedback for the client, and you need to understand these codes. You need to understand them and memorize them because it's really important. Next, we have data formats. I would say JSON is the undisputed standard for RESTful APIs due to its simplicity, readability, and widespread support. I have never seen anything else than JSON in RESTful APIs. If you have seen anything else, you just say it in the comment section below. Versioning. Versioning, basically, how do you handle changes to your API? Let me delete this because we don't need to talk about this one. So how do you handle changes to your API over time without breaking existing clients? We will use URL versioning. For example, like we will have like v1/users and v2/users, v3/users. It's pretty simple and explicit. And the header, you will have some sort of header versioning, like you can do it in the header versioning. This is, we call this a URL versioning. There is an header versioning as well. It's cleaner to the URLs, and the users doesn't know, the client doesn't know what's going on. Next we have authentication and authorization. Basically here, how clients prove who they are and what they are allowed to do. Common methods include like APIs, OAuth2, and JW token, which is basically JSON Web Tokens. And number 5, I would say error handling. To provide consistent machine-readable error response, typically in JSON, including an error code message as well, and potentially some details to tell you what's going on. And number 6 is filtering, sorting, and pagination. For retrieving collections of resources, you would use like something like query parameters. Like if we talk this like version 1/user, you use a query parameter like you start with a question mark. Basically, we're starting here the query, and we want all the user that have status equals to true. This one is for filtering. You can make like for sorting, you can add some pagination, limitation, things like that. Here we have rate limiting and throttling. It's crucial to protect your API from abuse by limiting the number of requests a client can make within a given frame time. Okay, how to ace the interview discussion? In an interview, don't just list these principles, like apply them to the problem. If you asked to design a user management API, for example, immediately talk about users as resources. And the get will be for retrieve, post for create, put for update, and delete to remove. And you need to justify your choices, and basically I would use URL versioning for clarity and the HTTP status code for robust error handling, things like that. And I would say by really understanding the previous section, which is in the key practical aspects in your RESTful design, and by just putting all of these aspects together to build your API in your API design interviews, I guess you will be succeeded. So RESTful API design is more than just a set of rules. It's a philosophy for building scalable, maintainable, and highly interoperable web communication layers. Mastering its principles will make you a far more effective system designer and impress any interview. Thank you for watching this video, and see you in the future.